All right, so NASA, speaking of very cool, is doing something awesome today. They're trying to land on an asteroid. NASA man is standing by.
That's right.
More about that.
We are a go. Are we a go for this interview? Are we a go? Get the thumbs up. We've got Jason Dworkin here. He's a NASA scientist. How long have you been working on this project, sir?
So I've been working OSIRIS and OSIRIS-REx since 2004.
Wow.
It took 3 tries to convince NASA to invest in this mission, and then we were selected in 2011, and then it's designing and testing and building and launching in 2016, arriving in 2018, and sampling today.
Now, why did it take 3 shots? It seems like going out and touching an asteroid and finding out what's inside of it would be like a very important thing to know. Why did it take 3 shots? Just so expensive?
I think so. NASA has a lot of priorities. This is a competitive mission in the New Frontiers class. PI-led, Professor Dante Loretta at the University of Arizona. And so it's a competitive process. And so instead we got other missions that are also exciting. NASA has to choose.
Okay, so explain to folks what's going to happen today and just how hard this is, because I can't imagine there's too many things more difficult than landing on an asteroid.
Well, we've already rehearsed twice, and they went perfectly, so we're ready. The asteroid is 18.5 one-way light minutes from Earth right now, and so this is all autonomous. This morning, we handed the keys over to the spacecraft, so it's on its own. The spacecraft will depart orbits, which is actually a world's record smallest orbit around the world's record smallest object ever orbited by a spacecraft. And then do a few maneuvers to line itself up with the sampling site called Nightingale, and make sure that it's lined up. It uses its autonomous computer system. It uses cameras to track landmarks, just as you would when you're driving around, to make sure it's on track to touch the sampling site. It is a 8-yard diameter sampling circle, which is far smaller than we had planned because the asteroid turned out to be a lot rockier than our data told us it was when we planned the mission. So we went from 50-meter circle to an 8-meter circle, which is very small. The spacecraft will autonomously descend to the surface. Actually does a free fall, but the gravity is so low that free fall takes 20 minutes.
Wow.
Touch to the surface. There's a 10-foot long pogo stick that has dinner plate size, like an old car air filter on the end of it. Shoots a jet of nitrogen gas, and when touched to the surface, shoots the nitrogen gas that scoops up regolith, that's dust and rocks and dirt from the surface of the asteroid. If the spacecraft decides that it is headed towards a hazard, it can abort the mission and we can try again. If we touch the surface and we expend the nitrogen gas and don't get enough sample, we have 2 more canisters. We can try again. After that, the spacecraft will go up, leave orbit, leave the asteroid, do a health check, send back telemetry. We'll have a movie of the descent, the sampling, and the ascent. Over the weekend, we'll spin the spacecraft, and that spin maneuver measures the moment of inertia as we hold the 10-foot long arm out and weigh how much sample we got, decide if it's enough, and then we can stow the sample in the sample return capsule. In the spring, the spacecraft has just like there's a launch window to leave the Earth, there's a departure window to leave Bennu and come back to the Earth. That opens up in the spring. The spacecraft comes back to the Earth in September 24th, 2023.
All right.
Just before 9...
Sorry about that. We're running out of time, but that's so exciting. You've been coming back, but it's going to take a little while. So we'll check back in with you when it comes back and find out everything that's on the thing. I really appreciate it. This is so exciting to me. So exciting. All right, stick around. We got more on the big show. They're going to get a sample and send it back. This is incredible.